Now we're given summation of x as 960.1, summation of x squared 92,274.44 with the sample size n is equal to 10, and also summation of y 748.2, while summation of y squared is equal to 70,041.16, a sample size of 8. The data are randomly sampled from normal distributions with the same variance. Find a 90% confidence interval for the difference in mean. So the first thing I would do, I'll calculate the mean of x. So the mean of x, we're going to take summation of x, which is 960.1, and all of that divided by 10 is supposed to get 96.01. So that's the mean of x. And as for the mean of y, it's going to be 748.2 divided by the sample size of 8. That leads us to 93.525. Now, if the sample variances are given, then we know that S sample size, the standard deviation, I would say rather, or the variance is equal to n minus 1 times S sub x square plus ny, that is nx, and this one is ny minus 1 times s square sub y divided by nx plus ny minus 2. So we're going to be using this. So the first thing we're going to do is we're going to try and calculate s double x, which is basically summation of x squared minus the summation of x all squared divided by nx. So that's basically 92,274.44, which is summation of x squared that's been given here, minus 960.1, and all of that to the square divided by 10, and this is going to lead to, from your calculator, 95.239. The next thing, I'm going to calculate the s double y, which is basically summation, that's the variance of y basically, of y squared, okay, minus summation of y all squared over ny, the sample of y, and that's going to be 70,041.16 minus 748.2 to the square, which is this one, divided by the sample size for y. That leads to, this is 8, and if you were to do the calculation, you get 65.755. So now we're going to try and do this, the variance of both samples. So this is s squared, alright, p, which is equal to s double x plus s double y, which we found there, those two, alright, and divided by the summation of both samples. We add up both samples, nx plus ny, and then minus 2 from the formula, and that's going to give you 95.239, okay, plus 65.755 as calculated here, divided by, of course, the sample size is 10 plus 8 and then minus 2, and if you were to do this calculation, should be able to get 10.062125. Now the confidence interval can be calculated by using mean of x minus mean of y plus or minus, okay, the t value, alpha over 2 times n of x plus n of y, okay, minus 2 times s sub of p square root of 1 over nx plus 1 over ny. So this is very simple now. So we take the mean of x, which we have calculated as you've seen before, and this is 96.01 minus the mean of y, which is 93.525, okay, plus or minus our t value is going to be, so what we're going to be using now, we're going to be using a t value for 0.95 and then 16. And if you check this from your statistic table, you should be able to see that it's 1.746. Now, basically, how do we arrive at 1.95? You might have learned at your A-level maths that if you were to calculate a 90% confidence interval, so basically you're going to take 1 minus 0.9 and then divide it by 2, and because you divide it by 2, so you take 1 now minus this is going to give you 0.95. So we're looking at those two values here, those two areas, I would say. And so that's why we're using t 0.9516, and when we check this from our table, we're going to get this value here, 1.746. So this is 1.746. Multiply, if 1 over nx, okay, and multiply by the standard deviation first. Okay, we shouldn't be forgetting that. Okay, our standard deviation was this 10.0, so 10.062125, and then times the square root of 1 over nx, the sample of x is 10, plus 1 over sample of y, which is then 8. And all of that's going to lead to 2.485 plus or minus 1.746 times, do this from your calculator, this is what you get, and therefore a 90% confidence interval, alright, is going to be equal to 90% confidence interval is going to be then minus 0.142 and then 5.112. Of course, there's a plus and a minus. You do the calculation here, you add it up, you should be able to get the upper limit, and you do the subtraction from this, subtract all of that from here, you will get the lower limit. So this is our answer to this question, and I hope that has been of some help. So basically, this is the confidence interval in inferential statistics for further maths advanced level. Take care.